Hey, everybody. Welcome to Science Friday number 10. This week, we're going to talk about electric vehicles, which I think is something that may have a high degree of native interest for a lot of you. It's a complex topic, and we can't get into it in a lot of depth in just 10 minutes, but hopefully we'll be able to get into it enough that you'll be encouraged to go out and do a little bit of research on your own. There's a lot of good information out there on the internet about electric vehicles. And then I'm not going to paywall this episode this week because we have about 50 new subscribers to Howlin just this week, and I want those folks to get a chance to look at Science Friday. It's one of the only things that we paywall on this site. So normally you'd have to be a paid subscriber to see one of these. So electric vehicles, by way of full disclosure, my family and I own an electric vehicle, and we like it. Now, it's not a panacea. It is very good for a particular application that we have. So for some people, in some particular applications, I think EVs are very, very good. But they're not for everybody. And it's really difficult for you to replace your fossil-fueled vehicle, liquid-fueled vehicle, with an EV if that's the only car that you have. There's going to be some things that you're not going to be able to do. So let's talk a little bit about EVs. And in order to do that, we have to define some terms. And I'm just going to go down the list of these terms, and we'll define them as we go through our discussion. The first is something called energy density. And energy density is the term that scientists and engineers use when they want to compare one source of energy to the other and make sure it's an apples to apples or an oranges to oranges comparison, instead of an apples to oranges comparison. The next term is an order of magnitude. That's just a power of 10. So if I go from 1 to 10, that's 1 order of magnitude. If I go from 1 to 100, that's 2 orders of magnitude. And that is, again, a term that scientists and engineers use when they're comparing energy densities. Are EVs emission-free? That's a claim that I see bandied about quite a bit. We need to dig into that to see whether or not it's true. We're going to talk about the second law of thermodynamics a little bit. We're going to bring that in because it discusses the efficiency of heat engines. We're going to talk about battery issues in EVs, and there's a whole host of them. The range of EVs, which is a concern to a lot of people, and a legitimate concern, especially in cold weather. The cost of owning an electric vehicle versus a conventional car. There's quite a bit of difference in cost in some cases. Finally, the effect that EVs have on the grid. So let's just go down the list real quickly. The lowest energy density that you're going to find in sources of energy that we use to power anything happens to be renewables, solar and wind. The energy density of renewables happens to be a couple of orders of magnitude less than fossil fuels. Now, that doesn't mean that renewables are bad. I'm a big fan of both solar and wind. They're very useful as far as they go. But they do have some drawbacks. And we're not here to talk about renewables today, but one of the drawbacks of renewables that's applicable to electric vehicles is that the energy density is just really low. So if you're trying to power your grid just with renewables, you have to have an awful lot of whatever it is. So you have to have an awful lot of wind turbines. You have to have an awful lot of solar panels. The wind has to be blowing and the sun has to be out. So one of the reasons that fossil fuels have been so attractive for so long, and the liquid fossil fuels are things like oil and gasoline and diesel/kerosene, and then the solid fossil fuel is coal. The reason those have been popular for so long is because the energy density is a couple of orders of magnitude higher. There's a tremendous amount of energy that you could put in a gallon of gasoline. It's actually fairly amazing. And, set one on fire sometime if you want to get a firsthand demonstration of what that is. A similar size battery doesn't pack anywhere near the energy density as a gallon of gasoline. Now, above that, several orders of magnitude, even greater still, is nuclear power. And if you're going to build these big grids that are going to power these fleets of electric vehicles, you're probably going to have to go to nuclear power to do it. You're not going to be able to do it with fossil fuels and then accomplish what you wanted to accomplish in the first place, which was to clean up greenhouse gas emissions. And you can't do it from the renewables because the energy densities are too low. You'd basically have to coat everything with solar panels. You'd have to put wind turbines everywhere, and there's some deleterious effects to doing that. Now, are electric vehicles emission-free? Well, no, absolutely they're not. They're not emission-free for a whole bunch of reasons. Just because you don't get any, there's no tailpipe, there's no emissions coming out that car. It doesn't mean that it doesn't create emissions, it just doesn't create them at the source. Something had to power that electric vehicle, and probably what that was right now was not renewables, and it was not nuclear. It was a fossil fuel powered grid. So all you've done is transport the pollution that the car creates from where you live to wherever the power is generated. Now, there is a net benefit to this, and that's where the second law of thermodynamics comes into play. The second law of thermodynamics, which limits the efficiency of heat engines, applies to automobiles, ones that are powered by fossil fuels. So it's complex, and I don't want to get into it, but basically 35 to 40% efficiency is all you're getting out of most internal combustion engines. Now, so every car is successful at converting only about a third of the energy that's in the fuel that it burns into moving the car down the road. That's a rough way of putting it, but it's roughly accurate. Now, in an electric vehicle, whatever energy's in that battery, it goes, some of it's lost due to heat, but most of it goes right into propelling the vehicle down the road. And that's good. But you had to generate that energy from somewhere, but there's a net benefit because the second law of thermodynamics doesn't apply to the entire fleet. It only applies to the power plant if it used a heat engine to generate the electricity. So it only applies one time instead of in every individual vehicle the way it would in a conventionally fueled car. So you get a little bit of a net benefit there. But they're not emissions free. Even the manufacturer of the car creates a lot of emissions, some pollution, some toxic waste. So they're not emission free, and they're not as green as many people would have you believe. Whenever you make anything in big enough quantities, it creates some issues. Now, let's talk about battery issues with EVs. The biggest issue is that right now, the lithium ferrous batteries or lithium ion batteries that are used in EVs they don't have really high energy density. It's not as good as liquid fuels. So you have these big batteries, they're really, really heavy, and they don't store a ton of energy, at least not in terms of energy density. There's a lot of energy in there. And set one on fire if you want to find that out for yourself. Try to put out a fire in an electric vehicle. You just got to watch them burn because there's a lot of energy in that battery, but it's not as good as it would be if you had fossil fuels. So you've got this battery. It can only store a certain amount of energy, and we're going to have basically a big advancement in battery storage technology, I think, before you start getting the range out of EVs that people really want to see. Right now, it's between 200 and 300 miles in most of them, depending on exactly how they're configured. Heck, I have a diesel truck outside of Dooley with a 50-gallon tank in it that'll go 800 miles unloaded on a single tank of gas. When I'm pulling my big old trailer, it'll still go 450. EVs don't get you anywhere near that. The batteries in EVs aren't efficient at low temperatures, so in cold weather, you don't get the range that you get in warmer weather. The materials that are necessary to make the batteries, lithium and some other relatively rare elements, rare metals, they come from places in the world that aren't the best places, and they're often mined in circumstances that are socially bad. The people aren't treated very well that do a lot of the mining. And then finally, what do you do with the batteries when they're done? Well, nobody's figured that out yet. It's really difficult to recycle lithium batteries, and the batteries of these EVs are big. And in a few years, when the first batch of EVs just became really popular in the past few years. And a lot of these EVs are still in their original batteries, but those batteries don't last forever. And when they wear out, you got to figure out what you're going to do with it. That's an awful lot of space in landfills or an awful lot of recycling that nobody knows how to do yet. So that's going to be a problem. By the way, if you buy an EV, make sure you get one that's got modular batteries so you can replace them a cell or a few cells at a time, and most of them are that way, but there are some EVs where if one cell in the battery goes wrong, you got to replace the whole thing and wait until you find out what it costs to replace the batteries in those things. If you do it a few cells at a time, it's something you can swallow, but the whole battery, you may be talking upwards of 15, 20K to replace the battery in one of those things. Now, the range. Again, the range of these things is not great. It's somewhere between 200 and 300 miles when the weather's warm, and that goes down when the weather's cold. And finally, the cost of the EV itself versus conventional. The EV we own is the most expensive car that we own, and we own some fairly expensive cars. I mean, we have a nice dually diesel truck. I have a Shelby GT350, and that little Ford Mustang Mach-E Premium that we bought is a fairly spendy vehicle. A lot of that was because when we bought it, they were hard to find, so the prices were really high. But you save money because there's no oil changes or anything like that. There's very little maintenance to be done on the thing, but service is kind of expensive when you take it in. Just because you got to take it to the dealer. So even though there's no oil changes or anything like that, if something goes wrong, the computer goes wrong or something like that, it's got to be dealer serviced. So you can't just take it to Joe's Garage or someplace like that and have it done where the work might be done more cheaply. Having said that, we have an excellent dealer here in town, and they've taken really good care of us at all of the service. The Ford dealer here is really good. Finally, if you do create these big fleets of electric vehicles, you're really going to have to do something to beef up the power grid, okay? We can't power fleets of electric vehicles off the power grid that we currently have. So that's it. I know that's not a lot. It's kind of light, but again, it's a big topic, and we could drill into any part of that a lot, but I just want to whet your appetite a little bit to go out and do your own research. So just to summarize, I think electric vehicles are good. They have a use, but they are not a panacea. They're not all things to all people. And if I just have one vehicle, it wouldn't be an EV because it wouldn't do everything that I need for a vehicle to do. It doesn't have the range, for one thing. And in cold weather, you've got some significant issues. They take a long time to charge. We built a nice charging station for ours here, but if you just plug it into, a standard wall outlet, they charge really slowly. So there's some things that you have to think about there that you're never going to have to think about with a conventional vehicle. When you charge the things up, even if you go to a fast charger, you're going to be there for maybe 45 minutes to an hour. And how long does it take you to fill up a tank of gas in your car? A couple minutes, and you're back on the road again. So when you're trying to do long trips, it takes some additional planning. All right, that's it. I'll be seeing you. Cheers.